evening and welcome to Tinkering with Edkelar. To mix things up a bit again, I got a rather unassuming box here. The keypad gives it away as a calculator. And an old one at that. It is made by Sanyo and the model number is ICC-82D. The ICC apparently stands for Integrated Circuit Calculator. That's another indicator on the age. Nobody would bother pointing out that there's ICs in their electronics if it weren't a novel new thing. The design is from the late 1960s to early 1970s and it uses Nixie tubes for a display. Originally it came with a power brick and carry case, but the one I got here had neither. The price tag was good though, since it was also sold as not working. On a side note, this specific model had at least one more variation where they used 7-segment style neon tubes for the display. I'll put a link to a Curious Mark video in the description where he has one of those on the bench. And one of those two variants, not sure which one, has been used by the prop department of the original Ghostbusters movie to make a random piece of equipment that doesn't even do anything in the movie. But for that reason, these are very rare to find in a complete calculator condition. So let's have a peek. Besides a bit of expected dirt, there are only a few minor nicks and dings in the case. The display cover opens without issue too. So let's open it up. The case is held together with 4 screws. Ew, disintegrating foam! Everywhere! Yuck! The white block in the center is a battery pack. So yes, this can be counted as a pocket calculator since it does work mobile. The arrow and arrow indicators are regular neon bulbs behind a little cutout. Those are easy to replace if needed. The Nixies... oof, don't ask. Getting the components out. The keyboard is also a rather interesting design. Magnets on the keys and reed switches in the frame. And even more foam in the keyboard area. Next, trying to get the PCB out. It seems to be held down somewhere in the center, and since I didn't want to use any force here, I kept poking at it very carefully. I thought the power socket was somehow holding it back, so I removed that next. But it turns out that it's just the blue card edge connector. It is held in a little recess on the bottom and needs to be wiggled free before it will allow the PCB to lift up. Up next, the top cover. I really need to get all of the components out, since this needs a good scrub in the tub. That little meter is a battery indicator. It just snaps in. And I couldn't help myself. I really wanted to try that thing and see if there were any Nixies broken. So I connected my power supply to the battery terminals and fed the expected 6.5 volts into that. Nothing. Not a single anything lights up. And yes, I did check the fuse. So up next, removing the flip cover mechanism. The flap is spring-loaded and the hinge elements are made of sheet metal bolted to the sides. There is also a microswitch on one side that is killing the power line when the flap is closed. Nice touch. The flap is stuck inside the cover. Apparently the recessed display piece is heat staked into the shell and you can't remove the flap while that is in place. Recapping. There's 3 electrolytics on that board. They need to go. And not just because it's me doing the job. All 3 were totally broken. This is most likely why nothing is working. At least they didn't leak over the PCB. I couldn't find a schematic diagram for this model, but since the Nixies run on about 200 volts, there must be a step-up converter hiding in here somewhere. I would bet it's the circuit under the Nixies. And with the recapping done, another quick test. Yay! I got Nixie output! Or at least, mostly. There is a bit of an issue. You see, that rightmost digit is blank and the leftmost one is a bit brighter than it should be. When entering numbers, the rightmost digit lights up, dim, and the digit is mirrored in the leftmost one too. Something is off here. While I think about what can be wrong with the display, I'll tackle the battery pack. Which is looking just as bad as one expects. Well, at least Sanyo didn't expect that. The manual says literally, the batteries never need replacing. Well, where can I claim my warranty? Getting the old, slightly swollen batteries out of the case is a destructive process. Once they start moving, it's easy enough. But that initial bump takes quite a bit of force. There are tiny silver cylinders in there too. I thought it might be fuses, but when I pulled on one, it turns out that those are early diodes. Turns out that the battery pack had anti-parallel diodes across each cell. This must be to avoid reverse charging. Nice touch. They all still work too, except the one that I decapitated, of course. Whoops. After a good clean, I start to put in new batteries. Since the cells I had around came with pre-welded tabs, I soldered those together as is. The joints are a bit on the thicker side for that reason, and the lid is now a snug fit. But nothing a bit of tape can't fix. I tried to reuse the wires from the original battery, but they are so tarnished I couldn't get any solder to bond. Just soot and more soot on the surface, even after sanding off the wire. And to make my life harder and the device a bit more fireproof, I also put in new diodes across the cell. Can't hurt, I think. I gave the battery pack a good charge on the lab supply. Now it's time to find out what's wrong with the display. I followed the traces and poked at signals. Nothing spectacular in the "how it's done" section. The 8 transistor stages in the center are the anode drivers for the Nixies, and they are multiplexed in a round-robin fashion, as is expected. The 13 odd white transistors on the side are the drivers for the 10 digits, the decimal point, and the 2 indicators. So far, so good. I can tell that the lower left chip is the display driver. It connects directly to the inputs of the transistors, and the outputs are clean signals. Odd levels for logic chips, but very clean rectangles. Where it gets weird is on the high voltage side of the transistors. You can clearly see that there is something wrong with the anode of the rightmost tube, and the leftmost one gets activated too at the same time, albeit at a lower level. Since I couldn't find anything on the PCB that would indicate crosstalk and the digital side is A-OK, I desoldered the 0 from the rightmost digit. And bam! Everything else started to work perfectly. I then desoldered the whole tube and checked. Yes, there is something off between the anode and the 0 segment in this tube. It should be open, but it comes across at 12 kilo ohm. Putting a bit over 200 volts across it did light up the 0, so the tube isn't completely gone, but the current draw was so high that the tube almost burned my fingers. As a last-ditch effort, I gave the tube a little shake and realized that the resistance changed slightly. Percussive maintenance? Let's try. Can't get much worse than it is. But indeed, after snipping my fingers at it several times and at various angles, suddenly, open contacts. I'm carefully optimistic. But nope, after soldering it in again, same as before. A few finger snips bring it back into working order again, but it keeps failing every now and then. This tube needs replacing. And as you might guess, Nixie tubes of this size are also extremely expensive, if you can even get them. This is an NEC LD8007 model. If anybody has an unused one lying around somewhere and is willing to part with it, please leave a comment. And cleaning the switches. The reed contacts don't need cleaning, of course. The keyboard also gets a scrub, but the keycaps are stuck to the plungers and wouldn't come off, so I had to clean around them. Putting things back together, starting with the power socket. And the PCB. Took a bit of time to wiggle the card edge connector into position again. Wiggling the hinge plates into place again. The keyboard needs to go into position next. And of course, the Microswitch. And that Microswitch is a last-minute headache. All the time during the test, I never clicked that switch and the calculator turned on fine. I had to assume that the lid would click it when closed, but no matter how I tried to mount it, it wouldn't work like that. Only a clicked when open position made sense. And that had me take a closer look. You can see here that the switch had been rewired before. The center contact is unused here, but has clear solder residue on it. Also, the wire on the other pin is an almost cold solder joint. That is not factory. After moving the wire back to the center pin, I realized why it might have been moved. The normally open position of the switch makes for very bad contact. Now I need to find a replacement switch. My switch drawer had one in it that was almost the same size. And after drilling out the mounting holes to fit and gluing the now loose cover back into place, I could mount that switch and bend the actuator bar into shape again. After a bit of massaging the wires into place and closing the lid, success! I got a working calculator out of it, at least as long as that tube wants to cooperate. Now to the elephant in the room. How to power this thing when the battery runs out? The power socket is rather odd. I made up a plug in OpenSCAD. And from another eBay listing I could get a picture of the original power supply. It delivers 6.6 volts and 7.3 volts. But which of the three pins holds which voltage? It took quite a bit of poking into the connections to find out what was going on here. You see, the socket has an integrated switch that will move one connection from an internal wire to the external pin. One might figure, hey, that should be the supply line, but no, not at all. Turns out that the battery positive side is the common pin and everything else is going via some other components. This socket is the rectangular version of center negative. The switched contact is the ground for the regular supply. That way, Sanyo could get away with one switch to provide both the 6 volt operational voltage and the 7 volt battery charging voltage. Only they need to be negative. So common on the first pin, -7 on the second pin, and -6 one on the third. Sheesh! A bit of 3D printing later, and I have a working case for the plug. The actual power supply will be a follow-up project. And let's give it a try. First and foremost, the reset circuit is almost non-existing. Even the manual says, after turning it on, be sure to hit CA before starting any operation. Without schematics, it is not easy to find out if and what components are broken. I'd expect some RC combination to create a pulse, but all the other caps are fine. I checked. The calculator can set the number of decimal places with the rotary dial. Entering a number is done the usual way. Note that while there are 8 digits visible, the calculator can handle up to 16 digits by shifting the display. That's what the double arrow button does. Addition, multiplication and division are easy enough. Like usual. Number, operation, equals. But subtraction is where things get, interesting. You see, this device doesn't have a way to indicate negative numbers. So it does like the old mechanical calculators did, using the 9's complement. Subtracting is done by just entering the second value and hitting the negative key. If you hit the negative key for a result, it will put it into the 9's complement. So it's up to the user to keep track of whether a number is positive or negative. So this is it. I did try to run and charge the device from my lab supply, and it seems to work with the pinout and voltages that I have. The only thing left to do is to make up a simple power converter. I'm thinking some DC converter brick to get from a regular 12 volt supply to the 7.3 volts and then a diode to get to the 6.6 volts, with individual current limits after that. It should work fine. I'll post an update once I get around to prototyping that. And that's it for this episode. I hope you enjoyed a peek into this piece of history. See you next time! I thought it might be fuses, but when I pulled on one, it turns out that these are tiny diodes. No, not tiny, they are not tiny at all. But the switches are stuck to the plungers. The switches are stuck to the plungers? That doesn't make sense.